Look up. Right now, above your head, the universe is performing a celestial ballet that hasn't been choreographed quite this way in decades, perhaps centuries. The year 2025 has already delivered some of the most spectacular astronomical events in recent memory. And we're not even finished yet. From blood-red moons hanging in our skies to ancient comets making their cosmic return, from meteor showers that turn night into a river of light to planetary alignments that echo the observations of ancient astronomers. 2025 has been nothing short of extraordinary. But here's what makes this year truly special. Many of these events won't happen again in your lifetime. Some won't occur again for hundreds of years. Others are genuinely unique moments in cosmic history, never to be repeated in quite the same way. And today, we're embarking on a journey through the celestial events that have already defined 2025. We'll explore the science, unravel the mysteries, and discover why these cosmic phenomena have captivated humanity since we first looked up at the stars. So dim the lights, expand your mind, and join me as we venture into the cosmos. Welcome to the celestial spectacle of 2025, the total lunar eclipse of March 14th, 2025 on. Let's begin our journey with one of nature's most dramatic performances, a total lunar eclipse. On March 14th, 2025, observers across the Americas, Europe, Africa, and parts of Asia witnessed something extraordinary. The moon transformed into a crimson orb, suspended in the darkness like a celestial ruby. But why does the moon turn red during a total lunar eclipse? The answer is simultaneously simple and profound. When Earth positions itself directly between the sun and moon, our planet casts a shadow into space. A shadow so vast, it can swallow the moon entirely. But here's the beautiful physics. Earth's atmosphere acts like a cosmic prism. As sunlight passes through our atmosphere, the blue wavelengths scatter away, the same process that makes our sky blue during the day, while the red wavelengths bend around Earth and focus onto the moon's surface. Essentially, the moon is being illuminated by every sunrise and sunset happening on Earth at that moment. Think about that. Every red and orange glow from every horizon around our planet, all focusing onto one celestial body. Ancient cultures called this the blood moon, and you can understand why. The Mesopotamians saw it as an omen. The Incas believed a jaguar was attacking the moon. The ancient Chinese thought a celestial dragon was devouring it. But modern science reveals something even more wondrous. We're watching light paint a portrait across 250,000 miles of space, creating a celestial canvas that changes minute by minute as Earth's atmospheric conditions shift. The March 2025 eclipse was particularly special for several reasons. First, it occurred during the moon's closest approach to Earth in its elliptical orbit, what we call a supermoon position, making it appear 14% larger and 30% brighter than when it's at its farthest point. Second, the eclipse lasted for an impressive 65 minutes of totality, giving observers a prolonged view of this cosmic spectacle. Dr. Sarah Chen, an astrophysicist at Harvard-Smithsonian Center for Astrophysics, noted something fascinating. The 2025 eclipse showed an unusually deep red coloration, likely due to recent volcanic activity in the Pacific Ring of Fire. When volcanoes erupt, they inject aerosols high into the stratosphere. These particles scatter blue light even more efficiently, making the red light that reaches the moon particularly intense. This connection between terrestrial geology and celestial phenomena reminds us that Earth isn't just a platform from which we observe the cosmos. We're participants in the cosmic dance, our planet's very breath affecting what we see in the heavens. If you were fortunate enough to wake before dawn on February 28, 2025, you witnessed something that hasn't occurred since 2005. 7 planets visible simultaneously in the pre-dawn sky. Venus, Saturn, Neptune, Mars, Jupiter, Uranus, and Mercury stretched across the ecliptic like pearls on a cosmic necklace. Now, let's be clear about something that often gets sensationalized. The planets weren't actually aligned in a straight line through space. That's virtually impossible and, frankly, irrelevant. What matters is their alignment from our perspective here on Earth, what astronomers call an appulse. Imagine standing in the middle of a circular room where 7 people are standing at various distances from you, around the room's perimeter. From your vantage point, they might all appear in a line along one wall, even though they're at vastly different distances from you. That's what planetary alignments are, a matter of perspective, of viewing geometry, but no less spectacular for it. What made the February 2025 alignment extraordinary was the inclusion of Neptune and Uranus, typically requiring telescopes to observe. But on this particular morning, Uranus reached a brightness just barely visible to the naked eye for observers in dark sky locations, while Neptune glowed at magnitude 7.9, easily spotted with binoculars. Venus, the morning star, blazed at magnitude 4.2, so bright it cast shadows in truly dark locations. Jupiter shone at 2.1, while Mars, Saturn, Mercury, Uranus, and Neptune created a spectacular chain across Pisces, Aquarius, and into Ophiuchus. Dr. Michael Torres, planetary scientist at NASA's Jet Propulsion Laboratory, explains the rarity. These alignments depend on the complex orbital mechanics of the solar system. Each planet has its own orbital period. Mercury races around the Sun in just 88 days, while Neptune takes 165 years. Getting 7 of them arranged in our sky simultaneously is like trying to synchronize 7 different clocks, each running at a different speed. It happens, but not often. Historical records show similar alignments observed by Babylonian astronomers in 185 BCE, and again during the Renaissance, when Galileo was pioneering telescopic astronomy. Each time, these events sparked intense astronomical interest and often astrological interpretation. But here's a thought experiment. What if you could view this alignment from Mars instead of Earth? The order would be completely different. Mercury and Venus, forever bound to the inner solar system from our perspective, would be nowhere near the lineup. Earth would take their place. It's a humbling reminder that our cosmic view is unique to our position, our moment in time, and our planet's particular path through space. The Venus-Jupiter conjunction of August 2025, fast forward to August 12, 2025, and we encounter another spectacular event, Venus and Jupiter. The 2 brightest planets appeared to nearly collide in the evening sky, separated by just 0.3 degrees, less than the width of a full moon. These great conjunctions happen roughly every 13 months, but they're rarely this close. The last time Venus and Jupiter appeared this near was in 2016, and the next won't occur until 2027, but not quite this close. What makes these conjunctions so captivating isn't just their brightness, but what they represent. You're watching 2 fundamentally different worlds, separated by hundreds of millions of miles, appear to touch. Venus, our hellish twin with surface temperatures hot enough to melt lead and crushing atmospheric pressure. Jupiter, the king of planets, a gas giant so massive it could swallow Earth more than 1/300 times over. Ancient observers couldn't have known these facts, but they recognized the significance of these meetings. The Star of Bethlehem, described in the Gospel of Matthew, might have been a Venus-Jupiter conjunction in 2 BCE, though scholars debate this endlessly. Chinese astronomers meticulously recorded these events, believing they presaged significant political changes. If there's one object that captured the astronomical community's imagination in early 2025, it was Comet 12P Pons-Brooks, affectionately nicknamed the Devil Comet, due to its peculiar outbursts that created horn-like structures in its coma. This Halley-type comet, with an orbital period of 71 years, last visited the inner solar system in 1954. Those who saw it then are now in their 70s or older. Those who will see it next are largely unborn. This is the temporal scale we're dealing with, a human lifetime compressed into a single orbital cycle. Pons-Brooks reached perihelion, its closest approach to the Sun, on April 21, 2025, passing just 0.78 AU from our star, about 117 million kilometers. For observers in the Northern Hemisphere, it became visible to the naked eye in late March and early April, reaching magnitude 4.5 at its peak. But what made this comet truly fascinating were its cryovolcanic outbursts. Dr. Elena Rodriguez, cometary scientist at the European Southern Observatory, describes the phenomenon. Comet 12P Pons-Brooks is what we call a cryovolcanic comet. As it approaches the Sun, subsurface ices, not just water, but carbon monoxide, carbon dioxide, and methane, rapidly sublimate. This creates pressure that eventually breaches the surface in explosive outbursts, temporarily increasing the comet's brightness by 100 times or more. These outbursts occurred irregularly throughout 2024 and into early 2025, sometimes creating distinctive two-pronged jets that resembled horns, hence the Devil Comet nickname. But there's nothing demonic about it. We're watching cosmic geology in action, observing processes that have remained essentially unchanged since the formation of our solar system 4.6 billion years ago. Think about that. The ice in Comet Pons-Brooks formed in the primordial solar nebula before Earth existed. Some of the molecules in that comet may have once been part of the cloud that birthed our sun. When you look at a comet, you're not just seeing an astronomical object, you're witnessing frozen time. In chemical time capsule from the birth of worlds. The mystery of Comet C 2023A3, Tsuchinshan Atlas. While Pons-Brooks captured attention early in the year, another visitor created excitement in the autumn. Comet C 2023A3, discovered jointly by the Tsuchinshan Observatory in China and the Atlas Survey in South Africa. This comet reached perihelion on September 27, 2025, and predictions suggested it might become one of the brightest comets of the decade, potentially reaching magnitude 2 or even brighter, easily visible to the naked eye even from light-polluted cities. What makes C 2023 A3 particularly intriguing is its orbital period. Approximately 80,000 years, the last time this comet visited the inner solar system, Homo sapiens were just beginning their journey out of Africa. Neanderthals still walked the Earth. The last ice age was in full grip, and mammoths roamed across continents. Dr. James Patterson, astronomer at Kitt Peak National Observatory, puts it in perspective. Long-period comets like this are visitors from the Oort cloud, that vast spherical shell of icy bodies surrounding our solar system. They spend most of their existence in the deep freeze, a light year from the sun, in almost perfect darkness. Something, maybe a passing star, maybe a gravitational nudge from the galactic tide, perturbed this comet's orbit 40,000 years ago, sending it on a journey inward. We're watching the conclusion of that ancient journey right now. The comet developed a striking anti-tail, a rare phenomenon where dust particles lag behind the comet's nucleus, creating an apparent tail pointing toward the sun rather than away from it. This optical illusion occurs when Earth passes through the comet's orbital plane, giving us an edge-on view of the dust sheet. Observations in early October revealed a surprising detail. The comet appeared to be fragmenting. Small pieces were breaking away from the main nucleus, each creating its own miniature coma and tail. This fragmentation isn't unusual for comets. They're inherently fragile objects, sometimes described as dirty snowballs, or more accurately, icy dirt balls. The stresses of approaching the sun, thermal expansion, sublimation pressure, rotational forces can tear them apart. If C 2023A3 completely disintegrates, we may be witnessing a comet's final performance. A cosmic swan song 80,000 years in the making. Or it might survive and return in another 80,000 years, when our descendants, if any exist, might have a very different understanding of the universe than we do. January 4th, 2025, brought us the peak of the quadrantid meteor shower, and what a peak it was. Under optimal conditions, observers reported zenithal hourly rates, ZHRs, exceeding 120 meteors per hour, with some locations claiming even higher numbers. The quadrantids are special among meteor showers for several reasons. First, they're one of the most intense annual showers, rivaling the Perseids and Geminids in activity. Second, their peak is incredibly sharp, a matter of just a few hours rather than the days-long peaks of other major showers. Miss that window and you miss the show. But here's the truly intriguing part. We're not entirely sure what created the quadrantid stream. Most meteor showers come from known comets. The Perseids are debris from Comet Swift-Tuttle. The Leonids come from Comet Tempel-Tuttle. But the quadrantids, they're associated with asteroid 2003 EH1 which some astronomers believe is actually the remnant nucleus of a comet that lost all its ice long ago. Dr. Jennifer Wu, meteor physicist at Western University in Ontario, explains, "The quadrantid parent body is fascinating because it represents a transitional object, something between an active comet and a dormant asteroid. By studying the quadrantids, we're essentially doing cosmic archaeology, investigating what happens to comets at the end of their active lives." The 2025 quadrantids were particularly spectacular because the moon was a waning crescent, setting early in the evening and leaving the pre-dawn hours, when the shower peaked, blissfully dark. Observers in North America and East Asia had optimal viewing conditions. And social media exploded with images and videos of brilliant fireballs, meteors bright enough to cast shadows, and leave persistent trains glowing in the upper atmosphere. One observer in Minnesota captured a quadrantid fireball, estimated at magnitude 6, brighter than Venus, bright enough to briefly illuminate the landscape. Analysis suggests this particular meteor was likely a piece of cometary debris about the size of a grape, entering Earth's atmosphere at 41 kilometers per second, nearly 92,000 miles per hour. At those speeds, the air itself becomes a plasma, creating the brilliant light we see. The Perseids and Geminids, summer and winter stars, no discussion of 2025's meteor showers would be complete without mentioning the Perseids in August and the Geminids in December, though we're speaking prospectively about the Geminids since we're still in October. The Perseids, peaking around August 12-13, coincided closely with the Venus-Jupiter conjunction, creating a double celestial spectacle. With the moon in a waning gibbous phase, the first part of the night offered excellent meteor viewing before moonrise. The Perseids never disappoint. These swift meteors, traveling at 59 kilometers per second, often produce bright fireballs and persistent trains. They're debris from Comet Swift-Tuttle, a large comet that last passed through the inner solar system in 1992 and won't return until 2126. What's remarkable about the Perseid stream is its age and evolution. Comet Swift-Tuttle has been leaving debris along its orbit for thousands of years, creating a complex, multi-stranded stream. When Earth passes through denser regions of this stream, called filaments, we see outbursts with higher meteor rates. Computer models of the Perseid stream suggest we're currently passing through material ejected by the comet during its Ayase 62 return, meteoroids that have been orbiting the Sun for 163 years, waiting for their brief moment of glory as they burn up in Earth's atmosphere. Think about the poetry of that. You're watching something that was once part of a comet, ejected during the American Civil War, that's been silently orbiting the Sun for over a century and a half. And in a fraction of a second, it creates a streak of light across the sky and ceases to exist as a distinct object, its atoms dispersing into the upper atmosphere to eventually become part of the air we breathe. As for the Geminids in December, predictions suggest excellent conditions with a slender crescent moon that won't interfere with viewing. The Geminids are unique. They come from an asteroid, 3200 Phaethon, not a comet. Though Phaethon behaves oddly for an asteroid, developing a short dust tail at perihelion. The debate continues whether it's a rock comet or something else entirely. If you've been paying attention to space weather news in 2025, you know we're in the midst of Solar Cycle 25's maximum phase, and it's proving more active than initial predictions suggested. The Sun operates on an approximately 11-year cycle, alternating between solar minimum, few sunspots, calm solar weather, and solar maximum, numerous sunspots, frequent flares and coronal mass ejections. We're currently at or near the peak of Cycle 25, which officially began in December 2019. What does this mean for us on Earth? More solar activity translates to more geomagnetic storms and more auroras. Throughout 2025, observers at mid-latitudes have been treated to auroral displays with unprecedented frequency. Aurora borealis sightings have been reported as far south as Arizona, New Mexico, in the southern United States, latitudes that typically never see the northern lights. Dr. Robert Hayes, space weather physicist at NASA's Goddard Space Flight Center, explains, During solar maximum, we see an increase in both the frequency and intensity of solar flares and coronal mass ejections. When a CME is Earth-directed, when it's aimed right at us, it takes about 1 to 3 days to reach our planet. When it arrives, it compresses Earth's magnetosphere, and charged particles spiral down magnetic field lines toward the poles. Those particles collide with oxygen and nitrogen in our upper atmosphere, and we get auroras. But 2025 has seen something more than just frequent auroras. We've witnessed what scientists call extreme geomagnetic storms, rated G5 on the NOAA space weather scale. These are rare events, typically occurring only a few times per solar cycle. The May 2025 solar storm. The most significant event occurred on May 10, 2025, when a series of X-class solar flares erupted from a massive sunspot group designated AR3686. This active region was enormous, more than 15 times the diameter of Earth, and clearly visible to the naked eye with proper solar filters. Of course, never looked directly at the sun. Multiple coronal mass ejections launched from this region, and through unfortunate, or fortunate depending on your perspective, timing, they merged into what's called a cannibal CME. Faster-moving plasma overtook slower-moving material, creating a combined wave of charged particles that slammed into Earth's magnetosphere. The resulting geomagnetic storm reached G5 intensity, causing several effects. First, the auroras. Reports flooded in from across the globe, auroras visible in Mexico City, Cairo, Mumbai, and even parts of northern Australia. The lights weren't just green curtains, but vivid reds, purples, blues, and whites. A full spectrum show lasting hours. Photographers captured images that seemed almost too vibrant to be real, but they were. Nature, it turns out, can outdo even the most saturated photo filters. Second, technological disruptions. High-frequency radio communications were degraded or completely blacked out in some regions. GPS signals showed increased errors. Some satellites experienced temporary anomalies, though none suffered permanent damage thanks to improved space weather forecasting and protective measures. Third, effects on power grids. Geomagnetic storms induce currents in long electrical conductors, like power transmission lines. Grid operators received advance warnings and took preventive measures. But some localized power fluctuations were reported in Canada and Scandinavia. Dr. Tamitha Skov, a well-known space weather forecaster, noted, "What made the May 2025 storm particularly noteworthy was the combination of factors: a strong CME, a southward-pointing magnetic field component, which allows better coupling with Earth's magnetosphere, and the storm's sustained duration. We essentially had a perfect storm of space weather conditions. The ongoing debate, solar prediction. Here's where things get controversial in the scientific community. Solar cycle 25 was initially predicted to be relatively weak, comparable to cycle 24, which was one of the weakest on record. But 2024 and 2025 have shown considerably more activity than expected. Some scientists argue this demonstrates limitations in our solar prediction models. Dr. Scott McIntosh, Deputy Director at the National Center for Atmospheric Research, has been vocal. We're still learning how the solar dynamo works, the complex interplay of magnetic fields, plasma flows, and convective processes deep in the sun that drive solar cycles. Our predictions have improved, but we're essentially trying to forecast the behavior of a gigantic magneto-hydrodynamic system using incomplete data. It's humbling. Others contend that the predictions were within acceptable uncertainty ranges, and we're simply seeing natural variability. Dr. Lisa Upton, co-chair of the Solar Cycle 25 Prediction Panel, maintains, solar cycles aren't perfectly regular. There's inherent variability, and our confidence intervals reflected that. Cycle 25 falling on the higher end of our predictions doesn't invalidate the models. It confirms we correctly assessed the uncertainty. This debate matters beyond academic interest. Accurate solar predictions are crucial for satellite operations, power grid management, aviation routing. High-latitude flights experience increased radiation during solar storms, and astronaut safety. As we plan for permanent lunar bases and eventual Mars missions, understanding and predicting solar activity becomes even more critical. Consider this. We've been systematically observing sunspots for only about 400 years, since Galileo's time. That's roughly 36 solar cycles. The Sun is 4.6 billion years old. We're trying to understand and predict a system based on observing 0.09% of its history. How well could you predict a person's behavior from watching them for 0.3 seconds of their entire life? That's the challenge solar physicists face, and yet they've made remarkable progress. The distant giants, Neptune and Uranus observations. While 2025 has treated us to spectacular naked-eye events, some of the year's most significant astronomical observations required powerful telescopes pointed at the distant ice giants of our solar system. The James Webb Space Telescope, now in its 4th year of operations, turned its infrared gaze toward Neptune and Uranus, revealing atmospheric details never before seen. These observations, released throughout 2025, are revolutionizing our understanding of ice giant atmospheres. Neptune, observed in January and July 2025, showed dynamic storm systems in unprecedented detail. A massive, dark vortex, similar to Jupiter's Great Red Spot but composed of different chemistry, was tracked from formation through evolution. Bright methane ice clouds towered above the main cloud deck, and compositional variations revealed complex atmospheric circulation patterns. What's particularly exciting is what these observations tell us about exoplanets. Many of the planets we've discovered orbiting other stars are Neptune-sized ice giants. By understanding our local ice giants in exquisite detail, we gain insights into potentially billions of similar worlds across the galaxy. Dr. Lee Fletcher, planetary scientist at the University of Leicester, elaborates. Neptune and Uranus are laboratories for understanding planetary atmospheres under extreme conditions. The pressures, temperatures, and compositions are very different from Earth. Yet the fundamental physics governing atmospheric circulation remains the same. By decoding how these ice giants work, we're developing tools to interpret observations of distant worlds we'll never visit. Uranus observations in March 2025 focused on its peculiar magnetic field and aurora patterns. Uranus has the most tilted magnetic field of any planet. It's offset from the planet's center and tilted 59 degrees from its rotational axis. This creates a wildly asymmetric magnetosphere and aurora that don't align with the planet's poles. JWST's observations captured these aurora in unprecedented detail, providing data that will feed models for years to come. Exoplanet discoveries, new worlds in the cosmic neighborhood. While not strictly celestial events in the traditional sense, 2025 has seen several significant exoplanet discoveries worth mentioning in our cosmic journey. In March 2025, astronomers announced the discovery of 2I 715b, an Earth-sized planet, orbiting in the habitable zone of a red dwarf star just 137 light-years away. What makes this world particularly intriguing is its size, almost exactly Earth size, and its orbital period of just 19 days. Now, inhabitable zone doesn't mean habitable. It simply means the planet receives the right amount of stellar energy for liquid water to potentially exist on its surface, if it has a surface, if it has water, if it has an atmosphere that allows appropriate temperatures. That's a lot of ifs. Red dwarf stars like 2I 715's host are the most common stars in the galaxy, comprising about 70% of all stars. They're small, cool, and incredibly long-lived. They'll shine for trillions of years. But planets around red dwarfs face unique challenges. They must orbit very close to receive enough energy, subjecting them to strong tidal forces and potentially intense stellar flares. Dr. Emily Rivera, exoplanet researcher at MIT, notes, "Every Earth-sized planet we find in a habitable zone is a piece of the puzzle. We're trying to answer one of humanity's most profound questions: are we alone? Each discovery refines our understanding of how common Earth-like worlds might be. And 2I 715b is particularly valuable because it's close enough, astronomically speaking, for follow-up studies with next-generation telescopes." As we move through the final months of 2025, several significant events still await. The Geminid meteor shower, peaking around December 13-14, promises excellent viewing conditions with minimal lunar interference. This reliable shower often produces rates of 120 meteors per hour or more, with many bright, colorful meteors that move relatively slowly compared to other showers. Jupiter reaches opposition on December 7th, positioning it directly opposite the Sun from Earth's perspective. This means Jupiter will be at its closest to Earth for the year, appearing largest and brightest. Through even a small telescope, you'll see the cloud bands, the Great Red Spot, weather permitting, and the 4 Galilean moons, Io, Europa, Ganymede. In Callisto, the same moons Galileo discovered in 1610, revolutionizing our understanding of our place in the cosmos. Looking ahead to 2026, we face a relatively quiet year for eclipses from most populated regions. But Mars reaches a particularly favorable opposition in January 2026, coming within 61 million kilometers of Earth, close enough for excellent telescopic observations. And then there's 2027, mark your calendars now. August 2nd, 2027, brings a total solar eclipse whose path of totality crosses North Africa, the Middle East, and the Arabian Peninsula. The duration of totality reaches an impressive 6 minutes and 23 seconds, one of the longest total solar eclipses of the 21st century, but the real spectacle comes on August 12th, 2045. A total solar eclipse will cross the continental United States from California to Florida, with totality lasting over 6 minutes in some locations. This will likely be the most watched eclipse in human history, occurring in one of the world's most populous and technologically connected nations. The longer view, cosmic timescales, let's zoom out further. Way out. The celestial events of 2025 are spectacular, but they're momentary flickers in cosmic time. The planetary alignments, meteor showers, and eclipses, they're products of orbital mechanics established billions of years ago and evolving on timescales that dwarf human civilization. The moon is slowly drifting away from Earth at about 3.8 centimeters per year, roughly the rate your fingernails grow. In about 600 million years, the moon will be too far away to completely cover the sun. Total solar eclipses will become impossible. The only eclipses will be annular or partial. Think about that. Total solar eclipses, those transcendent events that have awed humanity since we first looked up, are temporary. They didn't exist in Earth's distant past, when the moon was much closer. They won't exist in Earth's distant future when it's much farther. We live in a cosmic sweet spot, a narrow window of time when perfect total solar eclipses are possible. In about 5 billion years, the sun will expand into a red giant, eventually consuming Mercury, Venus, and possibly Earth. The beautiful yellow star that provided light for every eclipse, every aurora, every meteor we've discussed. It will transform into something unrecognizable. In about 4 billion years, the Andromeda Galaxy will collide with the Milky Way. If any observers exist on Earth or elsewhere, they'll witness a cosmic spectacular unfolding over millions of years. 2 galaxies merging, their spiral arms distorting, new stars forming from compressed gas clouds. These are the timescales on which the universe operates. Compared to these, human history is a microsecond. All of recorded civilization, from the first Sumerian cuneiform to the landing on the moon, to the observations of celestial events in 2025, encompasses just 5,000 years. It's 0.001% of Earth's history, and an incomprehensibly smaller fraction of cosmic time. Yet here we are, conscious matter that can observe, understand, and appreciate the universe. We're atoms that have arranged themselves in such a way that they can contemplate atoms. We're stardust that has become aware of stars. Let me bring this journey full circle by asking, why does any of this matter? In an age of pressing earthly concerns, climate change, political divisions, economic challenges, why should we care about planetary alignments or comets or eclipses? Here's my answer. Because we need perspective. When you witness a total lunar eclipse, you're seeing proof of cosmic mechanics that have operated for billions of years with clockwork precision. The same gravitational laws that govern the moon's orbit govern the formation of galaxies. The same physics that creates aurora governs the behavior of matter throughout the universe. These celestial events remind us that we're part of something incomprehensibly vast and ancient. They humble us. They put our daily concerns in perspective without making them meaningless, rather, by showing us the grand context within which our lives unfold. When I watch a meteor streak across the sky, a piece of cosmic dust ending a billion-year journey in a brief flash of light, I'm reminded of impermanence. Everything changes. Stars are born and die. Galaxies collide and merge. Comets sublimate. And yes, human lives begin and end. That's not depressing, it's liberating. It means this moment, right now, is precious precisely because it's temporary. When I see Venus and Jupiter appear to touch in the twilight sky, separated by hundreds of millions of miles, but aligned from my perspective, I'm reminded that point of view matters. Where you stand determines what you see. Two people observing the same conjunction from different continents see it slightly differently. What appears aligned from one angle is scattered from another. Perhaps that's true of more than just astronomy. When I learn about the light pollution that's stealing the stars from billions of people, I'm reminded that we have power. We've changed our planet's night sky in just a few generations. If we can do that inadvertently, imagine what we could do intentionally. We could restore the stars. We could solve our pressing problems if we applied the same ingenuity we use to understand the cosmos. The human element, here's something that doesn't get discussed enough. Every celestial event becomes meaningful only because we observe it. The universe doesn't care if a lunar eclipse occurs. It doesn't mark the occasion. There's no cosmic calendar noting, "Total lunar eclipse today." These events gain significance through human observation, human emotion, human meaning-making. An eclipse is just shadows and geometry until a human eye sees it and a human mind marvels at it. In that sense, we're not separate from the universe observing it from the outside. We're the universe observing itself. We're the cosmos made conscious, the universe's way of knowing itself. Carl Sagan famously said, "We are a way for the cosmos to know itself." Every time you look up at the stars, every time you track the moon's phases, every time you watch for meteors, you're participating in that cosmic self-awareness. The celestial events of 2025 are temporary. The blood-red moon of March will fade into history. The planetary alignments will dissolve as the worlds continue their endless dance. The comets will recede back into the darkness. The meteors will have burned themselves out decades ago by the time their light reaches the next star system. But the human response to these events, the wonder, the curiosity, the desire to understand, that's eternal. It's been with us since the first human looked up at a night sky filled with stars and asked, "What is that?" It'll be with us as long as humans exist. And if we're successful, we'll carry it to other worlds. Future humans, standing on Mars or Europa, or exoplanets we haven't yet imagined, will look up at unfamiliar skies and feel that same wonder. So that's our journey through the celestial events of 2025. From the blood-red moon of March to the 7-planet alignment of February. From the Devil Comet's return to the spectacular meteor showers. From the sun's furious activity to the quiet discoveries of distant worlds. It's been an extraordinary year in the cosmos. But here's the secret. Every year is extraordinary if you know where to look. The universe doesn't perform for us. It simply is, following laws that have remained constant since the Big Bang. But we can choose to pay attention. We can choose to look up. We can choose to wonder, tonight or tomorrow night or whenever your sky's clear, go outside. Give your eyes 20 minutes to adjust to the darkness. Find a constellation you recognize. Watch for satellites. Hope for a meteor. Just stand there and remember, you're on a planet, orbiting a star, in a galaxy containing hundreds of billions of stars, in a universe containing hundreds of billions of galaxies, and somehow, impossibly, you're conscious of all this. You can comprehend your cosmic address. You can feel awe at the scale and beauty of it all. That capacity for wonder, that's the real celestial event. It happens every time a human connects with the cosmos. It happened when ancient humans first tracked the planets. It happened when Galileo first turned his telescope skyward. It's happening right now as you watch this video. I want to know, what celestial event of 2025 most captured your imagination? Did you see the lunar eclipse? Did you catch the planetary alignment? Are you planning to observe the Geminids in December? And here's a bigger question. When was the last time you truly looked at the night sky, not just glancing up, but really looking, really seeing? What stopped you? What would it take to reconnect with the cosmos? Share your thoughts in the comments. Tell me about your celestial observations, your questions about the universe, or the astronomical event you're most looking forward to. Let's build a community of cosmic explorers right here. Remember, every expert astronomer started exactly where you are, looking up and wondering. The universe is waiting. Clear skies, everyone. Keep looking up.